Hi everyone. In this video today we will discuss advantages of FTIR spectroscopy. IR spectrometers can be divided mainly into two categories. The first one is the dispersive IR spectrometer, where we are going to use a source and monochromator. And second type of IR spectrometer is the Fourier transform IR spectrometer, commonly known as FTIR. This type of spectrometer uses non-dispersive analytical technique. So here the radiation is not split into different energies. Instead, it is sent as a single beam into the sample to produce the spectra of the sample. And this FTIR is one of the modern analytical technique compared with dispersive IR spectrometer. So today in this video we are going to see what are the three important advantages of FTIR and how it is more accurate and precise compared with dispersive IR spectrophotometer. All these things we will discuss in this video. So first of all, let us see the difference between the dispersive and non-dispersive IR spectrophotometer. In the dispersive IR spectrometer, we can observe the source which can send continuous radiation, and this radiation is going to be sent through the sample. Suppose these are the photons which are released from the source and they can enter into the sample. Some of this electromagnetic radiation can be absorbed by the sample, so that the remaining radiation can be sent to the monochromator. This monochromator is a filtering device which can filter the polychromatic radiation to monochromatic radiation. Now, what are the unabsorbed radiation from the sample can reach to the monochromator, where some of the radiation is going to be filtered by dispersive technique. That's why monochromator is a dispersing device, and this type of IR spectrometer is called as dispersive IR spectrometer. After filtration, the radiation can reach to the detector. Now the monochromatic radiation can enter into the detector to produce a signal of the sample. In this way, a monochromator is used in the dispersive IR spectrometer. Since IR radiation is less energetic radiation, this monochromator is placed after the sample in order to reduce the energy loss. But still, in the dispersive IR spectrometers, we can observe the filtering of radiation, so some energy loss can be observed, which affects the signal to noise ratio. But in the non-dispersive IR spectrometers, we cannot observe this monochromator. Instead, another device is going to be placed in between the source and sample. This is nothing but the interferometer. So through this interferometer, a single beam is going to be passed into the sample at each time, which is accurately measured. That's why interferometer produces non-dispersive IR radiation. So FTIR uses interferometer, which is a non-dispersive IR spectrometer. So in this FTIR, we can observe a fixed mirror and movable mirror. Now the source can send the radiation, which is going to be splitted by beam splitter. Now the radiation is going to be splitted to the 50% to the fixed mirror and 50% to the movable mirror. Once this radiation strikes to the mirror, they are going to be reflected back both from fixed mirror and from the movable mirror. And what of the radiation that comes after the interference is going to be sent into the sample. Since one of the mirror is movable, it can be moved at a specific velocity, which creates some path difference in the reflected beams. Now, because of this path difference, interference will take place, which results in a production of high amplitude single beam at each time, which is passed into the sample. So, without any dispersion, a single beam is passed into the sample at each time. So that's why FTIR is a non-dispersive IR spectrometer. Now let us see the advantage of this FTIR. So three advantages are there with FTIR. First one is the Fellgett's advantage. Second one, Jacquinot's advantage. And third one, speed advantage. We can remember these three as FJS. So let us go one by one. First one is the Fellgett's advantage. This is also called as multiplex advantage. We have seen that the source which produces a continuous radiation is then passed through the interferometer, which produces a path difference because of movable mirror, and it produces a interferogram where a high amplitude single beam is going to be produced at each optical path difference. Now this single beam is going to be passed into the sample, which produces the spectrum at each reference point within the interferogram. And this conversion is made by one of the mathematical conversion, Fourier transformation. In this way, single beam spectrum is converted into a complete spectrum of the sample. Each point in the interferogram gives the complete spectra. So we can have more number of points within the interferogram with respect to each time. So within a short period, we can get more number of scans in FTIR. In the dispersive IR spectrometers, it takes a lot of time for each scan. But in the FTIR, a number of scans can be produced within a short period. So the signals in the FTIR can be averaged, which increase the detection, thereby increase the signal to noise ratio. Because of more reference points, more scans can be done, which improves the signal strength. So signal to noise ratio is going to be increased in the FTIR. This is particularly very important in detection of macromolecules such as proteins, which requires FTIR for complete structural information. Second one is the Jacquinot's advantage. This advantage is also called as throughput advantage. So in the dispersive IR spectrometers, we can observe the monochromator, which is not present in the FTIR. The monochromator uses slits through which radiation can be enter or leave. Here slit width is very important to control the resolution of the spectra. Suppose the slit width is like this, some of the radiation can pass through the slit into the detector, and few of the radiation cannot pass. But when the slit width is very narrow, very few radiation can enter into the detector. So by reducing the slit width, we can reduce the radiation reaching to the detector, which results in the more energy loss and decrease in the signal. That's why in the dispersive IR spectrometer, as the resolution increases, the signal may be reduced because of decreased throughput into the detector. But in the FTIR, we cannot observe any monochromator. Instead, it uses interferometer. So we can observe increased signal to noise ratio. So SNR is going to be increased in the FTIR without any dispersion of IR radiation. Third advantage is the speed advantage. This also results in the high precision. Within the FTIR, we can observe the movable mirror is going to move at a specific velocity. This velocity can be measured very accurately at each time by using a laser beam. Suppose this mirror is moving like this. Then we can use a helium neon laser beam which can accurately detect the position of scanning mirror, so that at each time the frequency of IR radiation can be accurately measured. And this can take place within few seconds. So FTIR is having the high speed advantage as well as high precision. And the position of the scanning mirror can also be used as a reference point, such that we can get high precision in IR examination. So these are the three advantages of FTIR. First one is the Fellgett's advantage, which is the multiplex advantage, where each point within the interferogram can produce a single scan of entire spectrum. So by multiple scans, the signal to noise ratio is going to be improved. And second advantage is the Jacquinot's advantage, where monochromatry is not used in the FTIR. So energy loss is not observed, which again increase the signal to noise ratio. And third one is the speed advantage, which also results in the high precision. The position of scanning mirror is accurately measured by helium neon laser beam, which increase the accuracy as well as precision. And because of laser beam, this measurement is also very rapid, resulting in the speed advantage. So large structures like proteins can be easily analyzed by using FTIR spectroscopy within a short period. So these are the three advantages of FTIR compared with dispersive IR spectrometers. So that's for today. Hope you have enjoyed this video. If you like this video, please subscribe to our channel, share this video with your friends, post your comments in the comment box. Thank you for watching this video.